Hello, awesome Algebra 1 students, and welcome back. In this video, we're going to be going over how to graph a line when in slope-intercept form. So when we're asked to graph a line, that means we're trying to graph all of the possible solutions to a function. And these are called linear functions because when you graph their solutions, they tend to form a straight line without any bends or any curves. So how do you graph a line? Well, if you think about it, the only requirement to be able to graph a line are 2 points. If I put a point here and a point here, you could trace a line through those 2 points. But in order to calculate 2 points, you would have to do some input and output tables. I'd have to plug in values for X, do some simplifying, find our values for Y. So what's nice about slope-intercept form and what we have learned is that it doesn't actually require 2 points to graph a line. Instead, all you need is 1 point and what's called the slope of the line. Slope is how steep the line is. It's also called the rate of change, and it's how you get from 1 point to the next point on that line. Slope is a ratio, if we remember correctly. It's a ratio of change in Y over our change in X. Your change in Y is your vertical change. How far am I traveling up or down? And your change in X is your horizontal change. That's because the Y-axis is vertical and the X-axis is horizontal. So when you are given a function in this slope-intercept form, it's very simple to calculate a very specific point and the slope of the line. What do we notice about both of these functions? Well, both of them have Y by itself. They have a variable term containing X, and they have a constant at the end. We have a Y equals a variable term minus a constant, Y equals a variable term plus a constant. That's how you can tell that something's in slope-intercept form. When in doubt, is Y by itself? Chances are it's in slope-intercept form. Okay, so let's go ahead and get started. First thing is we need a point. Now to find that point, you could plug in anything for X. I could plug in 10, I could plug in -5, I could plug in 1, but here's the thing. Depending on, especially if there's a fraction, the math could start to become very difficult if you plugged in the wrong number. So there is a number that we mathematicians always like to use when we can because it makes our lives a lot easier. And that number is 0. Because when I plug in 0 for X, anything times 0 is always 0. So in other words, when I'm plugging in 0 for X, this becomes a 0 term. And what I'm left with is just Y equaling the constant at the end. So in other words, my point here is that I plugged in 0 for X. I ended up with -4 for Y. And if you notice, that -4 is that constant at the end. This specific point is called the Y-intercept, which is why this specific form is called slope-intercept form. Now, again, you don't have to calculate the Y-intercept. It's just the easiest one to do. So now that I have a point, I can't just graph a line with a single point. That's not enough information. And rather than trying to plug in again and find a second point, let's just use the slope. The slope is how the function is changing. And it's always going to be the coefficient of X, because this number multiplied by X is changing that value of X every time. Whatever I plug in for X, by multiplying it by 2/3, that value is changing. So my slope here is 2/3. So 2/3 is like a set of directions telling us where to go. Because it is a positive 2/3, that means my vertical change will be going up and my horizontal change will be going right. So basically I'm starting at 0, -4, up 2, right 3. That will take me to my second point on the line and all points after that. Let's take a look at our second example here. Y equals -4x plus 7. Again, step 1, we need a point. What point is the easiest point to find? Let's plug in 0 for X. Now, when we plug in 0 for X, the really cool thing about 0 is that it essentially eliminates terms. So -4 times 0, that's just a 0 term, and we're left with Y equals a +7. So in this case, our point was we plugged in 0 for X. We ended up with +7 for Y, and again, that point is called the Y-intercept because it's a point on the Y-axis. Now, we also need a slope. Again, the slope is the multiplier of X. What is changing X? Now, notice that slope is a ratio. It's a change over a change. So -4 doesn't show me both changes. So we have to change this into a ratio by putting it over 1. Now, what I like to say, and this is me personally, this isn't necessarily every teacher, I like to say the slope is always right. What does that mean? That means no matter what, my x change is always going to the right. So your y change will differ depending on whether it's negative or positive. So a positive slope, we're going to go up and to the right because our y change is positive. Negative slope, we're going to go down and to the right because our y change is negative. All right, let's look at some examples. We're going to do some examples on a worksheet, and then we're also going to do some examples using IXL. All right, here we go. First example using a worksheet. Again, all of these are in slope-intercept form. So again, in order to graph, we need a point and we need a slope. So the first thing I would recommend is plugging in 0 for x. Now, when I do that, again, this becomes a 0 term, and I'm left with y equals -4. Again, -4 is not a point. So remember, what a point represents what you plug in for x and then what you generate for y. So our point here is 0, -4. So I'm going to come to the y-axis because x is 0, and I'm placing a point on 0, -4. Now, if I go ahead and erase this, the second thing that we need is the slope of our line. Slope of our line, again, is change in y over change in x. That's always going to be the ratio of your slope. So I look at my equation, I look at my function, and what is changing x? What is connected to x? What's the coefficient of x? It's this here, this 5/4. Now, is 5/4 positive or negative? 5/4 is positive. So remember, the rate of change or the slope is always right. So if it's a positive slope, we're going to go up and to the right. So starting at our point here, I'm going up 5. 1, 2, 3, 4, 5, and 4 to the right. 1, 2, 3, 4. And that will take me to the second point on my line. So again, from here up 1, 2, 3, 4. Oh, looks like I went up a little bit too far. So let's try that again. Looks like I just went up a little too far. Erase, there we go. Again, that's why it's always important. It seems silly, but it's always important to double check your work. Let's go try that again. 1, 2, 3, 4, 5. 1, 2, 3, 4. There we go. That looks better already. So here we put a point there. I'm going to double check. 1, 2, 3, 4, 5 up. 1, 2, 3, 4 right. Now, I always like to use the slope to find all possible points on the line. Meaning, if I could, if this coordinate plane was bigger, I would keep going. But since it's not big enough, we're just going to go ahead and connect these two in a line. All right. And I'm going to extend that out a little bit further. And there you go. There is your line. Now notice, usually you want to put arrows at the end of your line because it means that that function is going to keep going and going and going. But that's how you do the first one there, graphing a line in slope-intercept form. Let's take a look at the second one here. Again, we need a point, and the easiest point is to plug in 0 for x. So when I do that, I end up with y equals 2, right? 0 plus 2 is 2. So that's the point 0, 2. So here, I'm starting at 0, going up to 2, putting a point. Let me get rid of this. Now, second thing that we need is our slope of the line. Look at the function, what's being multiplied by x. It looks like here, -3. Again, slope is our change in y over our change in x. -3 is not a fraction, so we're going to put -3 over 1. The slope is always right, so I know I'm going to be traveling 1 to the right. So what would a -3 change look like? Would that mean going up 3? I don't think so. Going up 3 is going to increase our value of y. So I'm going down 3 for -3. So here we go. See if I can do it right this time. Going down 1, 2, 3, and to the right 1, and that will take us to another point on our line right here. Now, in this case, I think I can keep going. So I'm going to down 1, 2, 3, right 1 again, 1, 2, up, and I've reached the end of my graph. Now, here's the interesting part. I like to find all possible points on the line. So I don't like to just stop with 3. In fact, it looks like there's another point, a fourth point somewhere up here. but I can't go down to get to that fourth point up here. So in other words, I can reverse the direction to find that fourth point. Instead of going down 3, I can also go up 3. And instead of going right 1, I can go left 1. And that leads me to that fourth point, because I like to find all possible points on the line. Okay, here we go. Let's go ahead and connect these in a line. And there's all of the solutions to that function. All right, these next two are a little bit tougher. So let's go ahead and look at those. Is it gonna come with me? I don't know. Nope, didn't. So we have to get rid of all of these. On to number 3. Okay, number 3 is a little bit tougher, and so is number 4. These are a little bit tougher examples. So let's start with the same thing. We need a point, so we're gonna plug in 0 for x, and that leaves me with y equals -4. So my point is 0, -4. Starting at 0, -4, put a point. The slope here is the tough one, because if you look at the function, what is x being multiplied by? There's nothing there. So remember, there's this thing called a hidden 1. X is the same thing as 1x. In front of any coefficient, there is a hidden 1. Or if you see something like this where it's -x, that's the same as -1x. That's just kind of keep that in mind. So here, the slope is actually 1, which as a ratio of change in y over change in x, that would be 1/1. Again, because the slope is always right, that means I'm going up 1 and right 1. So here we go, starting at our point, we go up 1 into the right 1, put another point, and then I like to go as far as I can. Up 1, right 1, up 1, right 1. And I find every single point that I can. And again, this is me. I look at this and I'm like, okay, well, I can't keep going this way, but if I go back to where I started and reverse the order, I'll be able to find 2 more points. Instead of going up 1, go down 1. Instead of right, go to the left, down and left 1. All right, now we're gonna go ahead and graph our line here. And there you have it. This has a slope of +1 and it crosses the y-axis at 0, -4. Okay, last one we're gonna do on this worksheet practice. This is another tough one because again, there's something that appears to be missing. So we need a point. So again, let's plug in 0 for x. When we plug in 0 for x, that creates a 0 term and we're left with y equals nothing? Like what is going on there? Well, remember, this has become 0. -4/5 times x is 0. So what we just found was that when x is 0, y is also 0. That's the point 0, 0, or what we call the origin. So just because there isn't a constant here doesn't mean that there's no y-intercept. It just means that that y-intercept happens to be 0. All right, the slope here is a little bit more straightforward. So for this slope, we have -4/5. So again, our slope is always change in y over change in x. Because it is a -4/5, I'm going to put that negative in the numerator because the slope is always right. So I'm going to travel 5 to the right and 4 down. So starting at my point here, I'm going to go down 4, 1, 2, 3, 4, and 5 to the right. 1, 2, 3, 4, 5, and place a point. Does that look right? 1, 2, 3, 4, 1, 2, 3, 4, 5. Yes. Now, there can't keep going in this direction because I've reached the end of my coordinate plane, but it looks like there could be a third point up here. And I like to make my graphs as exact as possible. So I'm going to go up 4, 3, 4, and 5 to the left. 1, 2, 3, 4, 5. And I can't go any further. So I'm going to go ahead here, grab my tool, and graph the line. Right there. And this didn't quite go past the coordinate plane, but if I had a little bit better tools, I would have been able to go past the coordinate plane right there. Awesome. Okay, so again, the process is pretty simple. Plug in 0 for x to get a point for y, the y-intercept, and then use the slope to find all other possible points on the graph. Now we're going to look at some examples from an online resource called IXL. Okay, this IXL code is UWB, Slope-Intercept Form, Graph, and Equation. And for this code, we're just going to go through some examples. It's a little bit different with IXL because you don't need to calculate all different points. You just need to calculate one. So I'm going to go through this kind of very similarly to what we did before. Again, if I'm looking at this function, I know I need a point. So that point's going to be, oops, I have the wrong cursor. Here we go. If I plugged in 0 for x, what's my y? And that y is -10. So that means my point here is 0, -10. So that's where my graph is going to start, way down here at 0, -10. Now, if I erase that, my slope is going to be the multiplier of x, which it looks like here is 5. So again, slope is your change in y over your change in x. 5 as a fraction is 5 over 1, which means because I'm always going right, that would require going up and to the right. So now I'm going to bring the mouse back, because here's how you would do this in IXL. I would grab the mouse and place a point first at 0, -10. From here, you'll start to see this line forming depending on where my point goes next. So if I go carefully and I go up 1, 2, 3, 4, 5, and write 1, you'll see the line form, because again, it only takes 2 points to graph a line. And if you were to check by going up 5 again, 2, 3, 4, 5, and write 1, it would take you to another point on the line. Up 5, write 1, up 5, write 1. We're going to go ahead and submit that and see if we got it right. And we did. Okay, let's take a look at this next one. Same idea. We need a slope and we need a y-intercept. So when I plug in 0 for x, that leaves me with y is -5. That is the point 0, -5. So coming down here to 0, -5. My slope of this line appears to be 9. Oops. So if my slope is 9, then that change in y, and I write this every time, over change in x is 9 over 1, which means I'm going up 9 and right 1. So if I place my point here at 0, -5, then I go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and right 1, my line forms, get rid of my drawings, and hit submit. All right, this one's a little bit tougher, or just a little bit different, because we have a negative slope. So let's try this one here. Again, plug in 0 for x, you get y equals -1. So that's the point 0, -1. That's where my graph is starting. Now let's get rid of that so we can actually see the slope. Up next, we need our slope, which is the multiplier of x, in this case, -8. So change in y over change in x. This would be -8 over 1. Since the slope is always right, this means we're going down 8 and right 1. So let's see, if I put my point here at 0, -1, I'm going down 8. 1, 2, 3, 4, 5, 6, 7, 8, and right 1. Now, something I want to point out is that you could have also gone up 8, 1, 2, 3, 4, 5, 6, 7, 8, and left 1 to find another point on the line, because again, reversing the direction allows you to find more points on the line. All right, so we'll do this as our last one because it contains a fraction, and then we will wrap up this video. Last one here, so we have plug in 0 for x, you get -6 for y, 0, -6. We need a slope of the line because you can't graph without 2 points, and the best way to find 2 points is to use the slope. So here it looks like our slope is a negative fraction. So again, change in y over change in x. I'm going to put the negative in the numerator, -1 over 9, which means I'm going down and to the right. So here we go. I'm going to place my point here, and I'm going down 1 and right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice how this is not a very steep line. That's because the less the slope, or the lesser the slope, the less steep the line is. All right. And again, if I had just changed my direction and gone up 1 and left 9, I still would have ended up with points on the line. And there you go. Okay, that concludes our video on graphing a line in slope-intercept form. Again, remember, it only takes 2 pieces of information, a point, which is most easily calculated using the y-intercept, and the slope, which is a ratio of change in y over change in x. If you want to make that a little bit easier to remember, remember that the slope is always right. So a positive slope will go up and to the right, and a negative slope will go down and to the right. Have fun graphing your lines, and I'll see you next time.